Okay, then here, next is the second method. The first method I'll call it single displacement, because there's only a single displacement here where magnesium metal displaces what? Hydrogen. Where does the chlorine go? It attaches itself to magnesium. Where does the hydrogen go? I always say choir. That no one to marry this side, that's gone alone this side. This is single displacement. Method. So the first method, we can call it a single displacement what? Method, of which it includes processes such as it includes a process such as filtration, evaporation, and what? And the crystallization. Okay? So the whole process that is involved is crystallization, of which crystallization starts with filtration, then comes to what? Evaporation, then you make crystals. And you collect dry samples or solid samples of any soluble salt. So this one, in short, we are saying this is a method of preparing all soluble salts. All soluble salts are prepared using this arrangement that we have seen here. All soluble salts. I didn't tell you that this method is for soluble salts only. Sorry. Let me make it clear that whenever you introduce a reactivity series, it's all soluble salts that we can prepare in this manner. Okay? So you can see here you said any mazit metal plus N acid. Okay? To give you the salt of your choice. For instance, now let's come to this one on top. Is it going to work if we say a metal plus acid? If we say metal plus acid, it will give us salt. For this one, these are very reactive metals. You cannot say a metal plus acid will give us a salt and hydrogen. These are very reactive metals. You cannot put them direct into what? Into acid. It's only the mazit metals that are less reactive that you can react with acids, not these. These you cannot put them direct into acid because they are highly reactive and very explosive reaction. If you put potassium or sodium or calcium direct into acid, we don't put 1, 2, 3. These three direct into acid. The key term here is what? Direct. You don't put these direct into acid because they are highly explosive. The reaction is highly exothermic and it can explode, even injuring you. So instead of using metal plus acid, we add them indirectly. We add them indirectly by using their alkalis. Okay? So it will be an alkali instead of a metal plus what? An acid. Then it will give us salt plus water. As I told you that methods of preparing salts, they just follow those chemical properties of acids. You remember an alkali plus acid makes salt and what? Water. Have you seen that? So when we introduce an alkali, you know an alkali is a soluble base. N soluble base or N base that dissolves in water. It is an alkali. For instance, the notable alkalis are 1. Sodium hydroxide and potassium hydroxide. We can also have this one, okay, calcium hydroxide. Then here you can put N acid. You can put N acid here. Acids that we can use, like if you want a chloride salt, you can use HCl. For a chloride salt, you can use HCl. Then for a sulfate salt, you can use sulfuric acid. Because the sulfate salt will come from this sulfate in sulfuric acid. The chloride salt will come from this chloride from HCl. If you want a nitrate salt, it is this one. If you want a phosphate salt, it's from phosphoric acid. So it goes on. The type of salt that you want depends on the acid that you are using, okay? So these are the acids. I'll give you an example of one of them. Okay, so an example of this is sodium hydroxide plus, let's say, HCl. Will give you what? This is sodium plus hydrogen chloride. Sodium will displace hydrogen ions here and will combine with what? Chlorine ion to form sodium chloride plus Z. Of course, here there's what? Water. That's the salt that we have formed, sodium chloride. By the way, sodium chloride is the salt that you use in our homes, okay, to put in relish, okay, so that now here you can, if you want a sulfate salt like sodium sulfate, you use sodium hydroxide and what? Sulfuric acid. If you want a nitrate salt like sodium nitrate, you get the nitrate from nitric acid. It goes on and on. If you want a potassium salt, you use potassium hydroxide with any of these salt of your choice. Have you seen, huh? So this one, you can see any reaction that involves an alkali and an acid. This one is a neutralization reaction. Because an acid neutralizes what? An alkali. So this one is a neutralization method. This is a neutralization method whereby here we use the single displacement. Here we use the neutralization method. So this neutralization method, to be actualized or to do it in reality, you have to use the titration. You have to use the titration. Okay? You have to use the titration. You know titration where you need a burette. Okay? Need a burette, then a conical flask like that. Huh? Okay? Then a stand holding this like that as titration. But here you put the acid, here you put the alkali and indicator. When the color changes, just know that a salt has been formed in the conical flask. So when this salt is formed, you undergo the same process.